Hello friends, myself Aradi Mahajan presenting my video on two-dimensional heat flow equation, nothing but Laplace equation. Solve the problem. Solve partial differential equation dou tu by dou x square plus dou tu by dou y square equal to 0 subject to conditions u is equal to 0 for x is equals to 0, u is equal to 0 for x is equals to pi. These two represent the boundary condition, and third condition u is equals to 0 when y tends to infinity. Using this condition we decide what is the possible solution. And the last one, u is equal to u0 when y is 0 for the condition 0 less than x less than pi. Differential equation is dou tu by dou x square plus dou tu by dou y square is equals to 0. We call this as equation 1. And as the condition is when y tends to infinity, u is 0, we consider let the solution be u, which is a function of x and y, as c1 cos of nx plus c2 sin of nx multiplied by c3 e raised to ny plus c4 e raised to minus ny. Equation 2. Therefore, when y tends to infinity, this u tends to 0. Therefore, this condition will satisfy for this solution. Therefore, we consider that as the possible solution. Then, using the condition, boundary condition, u is equals to 0 when x is equals to 0, or for x is equals to 0. In equation 2, we get left hand side as 0, right hand side is cos 0 is 1, therefore we get here c1, sin 0 is 0, therefore that term becomes 0, c3 e raised to ny plus c4 e raised to minus ny. Here the product of two terms is equals to 0. When x is 0, y is not equals to 0. And when y is not equals to 0, this term should not be 0. It implies the remaining term must be 0, that is c1 must be 0. Therefore, substituting that value in equation 2, we get u is equal to c1 0, therefore this term becomes 0. We get c2 sin of nx multiplied by c3 e raised to ny, c4 e raised to minus ny. Multiplying by c2 inside the bracket, we get this as sin of nx c2 c3, a new constant, we call it as c3 dash e raised to ny, and c4 into c2 is a new constant c4 dash e raised to minus ny, and we call this as equation 3. In equation 3, we use the second condition, u is equal to 0 for x is equals to pi. Therefore, using this in equation 3, we get left hand side as 0, right hand side as sin of n pi multiplied by c3 dash e raised to ny plus c4 dash e raised to minus ny. When x is equals to pi, again y is not equals to 0. And as y is not equals to 0, this term should not be 0. What it implies? It implies that the remaining term, that is sin n pi, must be 0. Last step, we have sin n pi is equals to 0. Transferring this to right hand side, we get n pi is equals to sin inverse of 0. And the value of sin inverse of 0 is standard value p pi. Therefore, we get n is equals to p. Substituting that value in equation 3, we get u is equal to sine of nx, n is p, therefore px, multiplied by c3 dash e raised to py, c4 dash e raised to minus py. We call this equation next fourth. Then using this condition number 3, u is equals to 0 when y tends to infinity in fourth. We get left hand side is 0, right hand side becomes sine of px multiplied by when y tends to infinity, this become c3 dash e raised to infinity, c4 dash e raised to minus infinity. All of we know that e raised to minus infinity is 0, therefore it becomes sin px multiplied by c3 dash multiplied by e raised to infinity. E raised to infinity is infinity, but here the product of this term, 3 term, is equals to 0. Out of this is not equals to 0. When it is for y tends to infinity, x should not be 0. It implies c3 dash must be 0. Once again, I will repeat that statement. E raised to infinity is infinity. When condition is given for y as infinity, x should not be 0. Therefore, this is not 0, this is not equals to 0. It implies the remaining term must be 0, that is c3 dash must be 0. Therefore, substituting that value in equation 4, equation 4 becomes u is equal to sine of px c3 dash is 0, therefore this term becomes 0, c4 dash into e raised to minus py. We write down the most general solution as u is equal to summation from p is equals to 1 to infinity. We replace c4 dash by cp sine of px into e raised to minus py as p changes from 1 to infinity, integer quantity. And then using the condition number 4, substituting the condition u equal to u0 for y equal to 0 in equation 5th, we get left hand side as u0, right hand side as summation from p is equals to 1 to infinity cp sine of px e raised to 0, e raised to 0 is 1. This represents right hand side of this equation represents half range sine series. and as it represents half range sine series, as per that technique, this constant Cp, nothing but Bn in that half range sine series, it is given by 2 by L, L is here pi, integration from 0 to L, 0 to pi, f of x is u0 into sine of p pi by L. The value of L is here pi, therefore p pi by pi into x, and therefore that becomes 2 by pi, integration from 0 to pi, u0, pi get cancelled, we get sine of px only, and its integration with respect to x. Therefore it is equals to u0 is constant with respect to x, therefore that I can take outside the integration sign. It becomes 2 u0 divided by pi, integration of sine standard result is minus cos of px divided by p, limits from 0 to pi, and therefore it is equals to 2 u0 divided by p pi constant term I will take outside, then cancel that minus sign by changing the limit. This become upper, this become lower. Cos 0 is 1 minus cos of p pi, when x is pi, it is minus 1 raised to p, standard value. Therefore we get the value of that Cp as 2 u0 by p pi multiplied by 1 minus 1 raised to p, and as this contains this type of term 1 minus 1 raised to p or 1 plus minus 1 raised to p, we require to find two different values. What is the value of that Cp when p is even number? Therefore if even, minus 1 raised to 2 we get plus 1, 1 minus 1 we get 0 if p is even. And if we consider the value of p as odd, minus 1 raised to 1, minus 1 raised to 1 is minus 1, that minus and this minus it becomes plus, 1 plus 1 we get 2, and into this, therefore we get that value as 4 u0 divided by p pi if p is odd. And as value exists for odd, we have to replace p by its general term as 2p minus 1, while substituting that in that equation number 5th. Last step we have the value of Cp as 4u0 divided by p pi, and that will exist for odd values of p, and as it exists for odd values we have to replace p by 2p minus 1 while substituting in that equation 5th, and therefore final solution we have u is equal to summation from p is equals to 1 to infinity, the value of Cp as 4 u0 divided by p is replaced by 2p minus 1 times pi, sine of px, p is again replaced by 2p minus 1 into x, and e raised to minus py, the value of p is replaced by 2p minus 1 times phi, is the required solution. Therefore, after substituting that value of Cp as 4 u0 by p pi, we get the final solution as u is equal to summation from p is equal to 1 to infinity 4 u0 divided by 2p minus 1 times pi sine of 2p minus 1 times x and e raised to minus in bracket 2p minus 1 times y as the required solution of that partial differential equation or two-dimensional heat flow equation. One more problem of similar type I will discuss in my next video. If you like my video, please share it as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you.